calculate the total number of angular nodes and radial nodes present in 3D and 4f orbitals. First of all, what is a node? The region where the probability of finding the electron is 0. For example, let us say we have a 2px orbital. Electron could be anywhere here or here, but in between at this particular region, the probability of finding the electron is 0. So, that is what we define it as a nodal plane. So, for p orbital, let us say for 2px orbital in this case, the angular node will be equal to 1, because for p orbital the value of L, the azimuthal quantum number, is equal to 1. So, let us calculate the total number of angular nodes and radial nodes for 3D and 4f. The total number of nodes is always equal to n minus 1, where n is the principal quantum number. So, we have two different orbitals, total nodes is equal to n minus 1. For 3D, what is the value of n? N is equal to 3. That means what should be the value of total nodes? Total nodes should be 2. And what is the value of L for d orbital? The azimuthal quantum number value is equal to 2. The total number of angular nodes is simply equal to the value of azimuthal quantum number, and therefore the number of angular nodes for 3D is equal to 2. How about radial nodes? Radial nodes in this case is equal to 0, because we already got the total value here. The number of radial nodes is always equal to n minus L minus 1. Therefore, in this case 3 minus 2 minus 1, and that is how we got 0 here. How about 4f orbital? In the case of 4f, the value of n is equal to 4, and for f orbital the value of L is equal to 3, and therefore what would be the total number of nodes? 4 minus 1, 3, and the angular nodes will be equal to 3, therefore the radial nodes will be equal to 0. This is simply 4 minus 3 minus 1.